Welcome to Virtual Process Control Laboratory. I am Professor Uttam. In the last class, we have discussed our open loop system for calibration of flow meters. Today, we'll see automatic using flow meters. That is the same orifice plate and the rotameter, and the same flow system with the pump which is falling in a tank, but we have replaced the manual operator with a controller and a control valve. These are the addition. This is a control system for flow control. Here you will find that the same inlet valve which is manually operated, it will be only operated once and you did not operate it again. To have a control over this flow rate, you can adjust any flow rate you want with the help of this controller and this control valve, which is a motor operated valve or MOV, and this motor is directed by the controller which gets the information from this DP cell transmitter as an electrical signal which comes out from DPCT in proportional to the pressure drop across the orifice plate, and the SRE is the current or voltage signal which is proportional to square root of pressure drop. That means this signal is proportional to the flow rate or velocity, and the controller measures this signal and compare with its set point SP, and the measured value is PV, is called process value or process variable, and compare this difference, and then it takes action automatically, and which will drive this motor, and this plug of this valve will be opened to that required amount of flow rate to this pipeline. It will be shown by this rotameter, and ultimately it will fall in this tank, and the level will rise with increasing flow rate. However, we can do the calibration work also in the manual mode by pressing manual valve, and you can also tune the parameters of the controller. Let us see what we do once this inlet valve is opened fully. Now we fully open this, and now you see that the motor operated valve is closed, and the controller is not in action. We can take say one is this set point, and we give this automatic pressed automatic. So you will see that controller will take action, and see it is the valve is opening and closing. In fact, you cannot see the inside of a valve in a field, but you can see the movement of the stem of the valve which is going up and down, and that can be checked also from outside. You see that the controller has controlled this flow in terms of this rotameter readings, and it's almost same. So you can increase it to 2. See, it is matching with 2 almost immediately. The controller is taking action. So you can also take it at 3, 4, 5. So very quickly the controller is making this flow rate same as the set point value. The controller is well tuned, so it is taking action. So you can also see the recorder here with the recorder and see what is the auto response. It is y-axis is 2.5 times divided. That means the 10 means 25, and here it is 85. So it is 85 multiplied by 2.5. So that is the maximum flow rate. We have seen that it is. We have increased this. This is the PV value, which is now almost same as the set point. Is the blue line. You see everywhere it is very quickly settling on these new set points. So it is increasing as we have wanted. So the set point and the PV value is matching here. If you go back And if you want to do some more experiments, say you want to reduce the flow rate from 6, so you can see that quickly the controller is taking action to make it the same flow rate as you desired, set point or HP. So it is falling. Now you can check the recorder also again and press the auto. See, this flow rate has come down. This is the maximum flow rate from where it is come down. So we can press it again to get the last 100-second result. So here you will see that flow rate was here, the maximum, then it step by step it is falling, and to around between 40 and 30, that is 35 into 2.5 is the flow rate here. As we have seen, it is 3, and in the recorder also it is 3. 3 means 35 into 2.5. So this way, this controller taking action. So you did not operate this manually operated valve. It is opens only once, and then whatever changes in the flow rate takes place, that will be taken care of by this motor operated valve, this is a control valve. And now if you want to increase the flow rate, you can increase, and we can also show the manual mode. This manually you can drive the valve by pressing the controller. That is, when we press auto, this controller take action according to control equation. This here it is a PID equation, proportional integral derivative equation. It is almost a very old system, and in that case also PID activity is still in use. Still it is used in the industry. Now if you press means manual, then you will see that SP is changed to power. So as the power is increased or decreased, you can also decrease it to 0. That means power applied is 0. This motor operated valve closes the flow rate, and if you increase this power gradually, you find that flow rate is also increasing. So you can go on increasing this. So this is manual action to check the control valve time to time, or when the controller is to be replaced. In that case also it can be kept directly manual. Now we can also see the recorder, view manual response. Well, there are output of the system are 3. That is, this is the pressure drop, actual pressure drop, and this line is for this DP cell transmitter, which is in terms of current, and this is the linearized current proportional to square root of pressure drop. That is, this is your pressure drop, and this corresponding equivalent in current, and this line is a linearized current which represents this pressure drop. So it is directly proportional to the flow rate. So you can see also the flow versus open loop system, that we have increased this flow rate from 0 to a maximum value. That is also shown here. It is in percentage. In this 85%, so it's showing there is a maximum flow rate, and we can see that the same tank is used here. We can also open this tank to drain this water out, and you can use the power to reduce this power to make it 0. So you can see that tank also can be emptied out, and if it is necessary, you can also calibrate with the help of this manual mode, similarly as we have done earlier. Now if you recollect all these things, this is the same pump, but this manually operated valve is fully open, but this control valve is closed by the controller. So here the supervisor is the controller which is taking action as a human being. And in place of a mercury manometer, we have used a DP cell transmitter, which is producing electrical signal proportional to the pressure drop across the orifice, and SRE is the square root extractor, which is producing current or electrical signal which is proportional directly to the square root of pressure drop, and so it is a linearized value of the flow rate. And the controller taking the differences when you in the auto mode. So if you have a different set point 4, you will see that the controller will take action immediately. So without handling this inlet valve manually, we can operate this system with a controller and a control valve. That's all I wanted to say for the control system. That previously we have discussed our calibration and flow meter, which was totally manual. Here we can do calibration as well as automatic control of the flow rate. Thank you very much for watching this video.